When two entirely different data streams collide in a sterile environment, their integration follows a specific mathematical sequence. Integrating contrasting melodies written centuries apart onto a single timeline follows rigid geometric logic. To isolate the physical variables of the mix, we must remove the distraction of timbre and instrumentation. You will hear no musical instruments in this video. We will use pitch ghosts, pure sine waves and mechanical hums to expose the raw, parametric scaffolding of the audio grid. That scaffolding is governed by 12 discrete rules mapped across 3 domains: harmony, space and rhythm, and advanced DSP. Mastering the exact physics of a mix requires stripping away the aesthetics to reveal the underlying mathematical framework. This diagram illustrates Rule 1. A melody is a shape, not a set of absolute pitches. Human cognition tracks relative intervals, not exact frequencies. Because a melody operates as a locked geometric unit, it can be displaced to any y-axis coordinate while remaining recognizable. Rule 2 introduces reharmonization. Consider the Song of the Volga Boatman, an 1866 composition originally anchored to a specific set of heavy minor chords. The harmonic floor can be swapped entirely, even borrowing chords from parallel keys, while the melody remains stationary. This modal mixture changes the emotional weight without altering the melodic shape. Rule 3 involves the quadlibet, or the precise vertical stacking of 2 finished independent melodies. For this stack to remain stable, the lines must move in opposite directions, with one line executing a rest whenever the other becomes active. Treat melodies and chords as independent modules. When the grid alignment is precise, a melody can even be completely divorced from the harmonic logic of the chords beneath it. Once harmonic alignment is solved, the focus shifts to physics. When 2 sound sources occupy the same part of the spectrum, they create frequency masking. Rule 7 resolves this overlap using vertical stratification. It treats the frequency spectrum like an apartment building. Sub-bass occupies the basement. The middle floor holds the body of the track, and high-frequency air is confined to the roof. A conflict occurs when 2 sources demand the same floor, such as a heavy orchestral passage from Modest Mussorgsky competing with a low-mid synth pad. Rule 8 uses sidechain compression as the temporal solution. When the dominant Mussorgsky block expands, the secondary block calculates an immediate volume reduction to clear the space. This is a trading time mechanic. One element is programmed to duck its volume whenever the dominant signal triggers a pulse. When the vertical acoustic space is entirely exhausted, sound engineers must use the parameter of time to force spatial coexistence. Beyond placement and volume, an engineer can alter the physical characteristics of a static, sustained texture. Rule 10 introduces the concept of granular synthesis. This is a violently destructive slicing mechanism applied directly to the fundamental audio waveform. Dividing a sustained chord into microscopic sub-100 millisecond shards restructures its fundamental harmonic properties. The original harmonic pad is now a fast, rhythmic percussion loop. Rule 11 uses spectral morphing to blend disparate textures by crossfading their specific frequencies rather than their overall amplitude. We can transition from a soft harmonic chord pad by Alexander Scriabin into a jagged industrial factory clang. The software trades dozens of frequency bands over time. The listener hears a physical transformation of the sound's texture rather than a standard volume crossfade. Advanced mixing requires the physical dismantling and reassembly of the audio's frequency components. Complex systems are built by the simultaneous execution of multiple rules. We establish the baseline physical structure using frequency allocation. A folk melody populates the top floor, and dense industrial audio takes the basement. We slice the basement's industrial mass into rapid percussive stutter cairns. Finally, a third unaligned melody beam enters the system. This divorce works because the layers occupy different registers. By maintaining strict frequency separation, the dissonance remains sharp and intentional. Finally, we apply Rule 5, dropping a temporary borrowed minor chord into the progression to shift the mood. This brief substitution casts a sudden shadow across the environment by drawing from the parallel key we established earlier. From this perspective, we see the entire functioning mechanism. 4 distinct rules are running flawlessly in tandem. Music theory and digital signal processing parameters provide the logic required to sustain high-density arrangements. These foundational rules provide the essential framework used to manage, organize, and seamlessly integrate multiple high-density audio streams